And one of the things that we did is that we went ahead and explored. So go ahead and get your notes out. The ones we took on Friday. It should be the last set of notes. But one of the things that we did is that we explored this. We explored quadratics again. Now it felt comfortable and safe for you just because it's something you saw before, and you saw, since algebra at least, they introduced quadratics to you, and this is the form they introduced it to you. And we found out that A played something pretty important. A will control, if A is positive, control if it opens up. It's negative, it opens down. It also dictated the vertex, like if it was the highest or lowest vertex. Now let's talk about the axis of symmetry. The axis of symmetry was important because it helped us. We're going to discover that at times when we're graphing, that if we have a point on one side of the parabola, then we have an identical point as a bonus on the other. So let's say I had a point here. I will have another point over here. And that's helpful because at times they will ask us to graph and they'll say come up with 5 points. And if we do, if I know one of them, I'm kind of giving the second one as a bonus. So that is something that's beneficial. We also came up with this vertex formula. And, well, we didn't come up with it. It was given. One of the things you do need to do is memorize this formula. You already have it written down. The thing I do want to add is that the vertex formula, once you found out what the vertex formula was, as a bonus, you all see the axis of symmetry, you will get that answered for you. So we have that additional to us. Now let's go ahead and actually talk about x and y intercepts. You already wrote this down, okay, so you don't have to write it again. But the thing I do want to point out is that when you look at a parabola, like let's say x squared plus 2x plus 1, the y-intercept was found easily because you all see the value of c. The y-intercept would be 0, 1. So it'll be very easy to identify the y-intercept. All you have to do is just take that last c value and put it down. Now the x-intercept was a little bit more involved. And we said because when we get to this step, you get to 2 things. Either factor, do this if you can, but if you can't, then you must do the quadratic formula. You must apply the quadratic formula because sometimes some of these are unusual factors, and if they are, like these decimal or these repeating factors, you sometimes have to use a quadratic formula. We talked about sometimes this is helpful so we won't do so much work. The part that we're really going to go over is this part here. How to graph using just the using the axis of symmetry and vertex and intercepts. What we're going to do is this. We have our vertex formula. Okay, so we're going to find the vertex and as a bonus get the axis of symmetry. We graph the vertex and the axis of symmetry. After that, we look for the intercepts. So we're going to look for the y and x intercepts and we graph those. If we're able to come up with 5 points, then we're good. We're done graphing. But you need to come up with all 5. So let's go ahead and practice an example. This is the exciting part we skipped on Friday. Write this down. Write down this equation. And then also make kind of like a little Cartesian grid with the x and y axis. Because we're going to graph this vertex. Well, not the vertex. We're going to graph this parabola. Using the vertex and 4 additional points. So that means in total we'll have 5 points. Now, if I called somebody randomly and asked them, write the vertex formula, you would kind of be wondering, do I know it by heart? Now, if you don't know it by heart, you're going to have to memorize it. And the reason being is because it's going to be necessary when we're dealing with quadratics to know that negative b over 2a and also the function of whatever number results from it. The reason why I say the result of that is because if you notice they're the same. That negative b over 2a is the same thing that's inside the function of the other one. So once we identify one, we know what the other one is, partially, at least part of the idea. So let's go ahead and identify our vertex. Now I'm going to make A, B, and C up here. Is everybody can identify B? Okay, so I'm going to do the opposite of it. So if you follow along, I will come up with a positive 8. And afterwards, I'm going to identify the A, which is a 2. So far, what I've done so far is just identify the B. So you see the B is negative A, and I took the opposite of it because it requires negative B. After that, I identify the A, which is 2, and place a 2 in there as well. Now, I'm going to leave this one blank, just because whatever I get from here is what's going to go in there. So in doing this, I find that 8 divided by 4 is 2, right? So I will get 2 as an answer here, which means 2 is really the amount that goes in there. Since they're the same, I get the benefit of using it over again. Now, the only thing I have to do is find out what f of 2 is. So I have this equation that I could do that. And where I will now come up here, I will use this to my benefit to see what is the y value that it results from it. So I'm placing 2 where all the x's are at. And then I apply the mathematical computation. Calculate activity, basically. I calculate it, write it down so you know what to do. Write it down, and then once I calculate, you can do it yourself, but this is one of the things you're going to find out. Being that if you trust me, you should get negative 5. Negative 5 should be your answer from this calculation, which means your vertex is really 2, negative 5. So my vertex is identified as 2, negative 5. So that's lovely because now I'm able to graph my vertex. Remember, what do I get as a bonus? Yeah, the axis of symmetry, right? Lovely. So I know the axis of symmetry too. So my bonus, my axis of symmetry is x equal to 2. I did steps 1 and 2, right? Graph the vertex, and then plot the axis of symmetry on the graph. So go ahead and do that in yours. Go ahead and plot down the vertex and the axis of symmetry. So far, good. Because we've done steps 1 and 2. We need still steps 3, 4, and 5. But step 3 is using the intercepts. So the first intercept we always want to start with is the y one. You might ask why? Well, it has to do with the fact that it's the easiest one to see. Now, if I called on somebody randomly, maybe I should, identify what the y-intercept will be. I'm going to call on somebody randomly. Oh, you know, I have a little random generator here. Da, da, da. All right, let me generate. 17. Who's 17? What number are you? 19? 19, so that'll be 18, so it'll be right over here. No, it'll be over here. No, it can't be this way. It has to be over here. You're 18, so you'll be 17. All right, so what would you get in that thing? What will be the y-intercept on this one? Well, this is easy. Once you discover it, you'll find out that it's very simple. It's going to be the answer 0, 3. Because you see the c value that's up there? It's just that. Whatever the c value is, it's 0, 3. It's because the y-intercept, let me write it down, y-intercept follows that its intercept is just the 0 c value. This being the c value being 3 dictates that, or follows that, my y-intercept is 0, 3. So that would be very easy to identify. Now, I'll be able to plot that as well to help me in my 5 points. But I get a bonus, yeah, on the other side too. So I get 3 points now. I have the axis of symmetry to assist me to know that I have another point over there. So lovely so far. The last thing I need to do is now, once I find the y-intercept, I'm going to move over to the x-intercepts. So for those, I need to take my parabola equation, 2x squared. Let's do 2x squared minus 8x plus 3 and set it equal to 0. So we're going to try to find out when does these y's become 0. Now the first thing you should think about is, can I factor? And we tried, at least tried. See, okay, we're going to use the A times C method. 2 times 3, which means I have to find factors of 6. 6 is 2 and 3, and 1 and 6, and also some negative reversals of each one. Now, I can't see really any pair in any form, shape that I could add up to -8. So it's not factorable in our sense. So we got to move over to the quadratic formula. So if you don't have the quadratic formula yet memorized, please take some time to memorize it. Now, the good thing is that you have time. Quadratic formula. I think in algebra, they just wanted you to use it. Now, in algebra 2, they probably wanted you to memorize it. You want to make sure you memorize it as well here. It's negative b plus or minus the square root of b squared minus 4ac over 2a. If you don't have memorized yet, take some time, write it down a few times, say it to yourself a few times, and apply it a few times, and you'll find out you're remembering. So, the nice thing about quadratic formula is that it's easy to apply. Just take some time afterwards to compute it. A, B, and C. So once we identify those, negative A means positive 8, plus or minus. B squared, my B is really negative 8. So I'm going to put negative 8 squared. Minus 4 times my A value 2 and my C value 3. And I'm going to divide that by 2 over my A value, which is 2. So I'll end up with this filled in quadratic formula for my quadratic. All the values have been filled in. After this is just a simplification process. We're going to make it simple, which means that I just compute. There you go. You're welcome. So let's go ahead and compute this. This is what we're going to do. 8 plus or minus. Now this is negative 8, so it's going to be 64. Negative 4 times 2 times 3, that's 24. And then we're going to have 4. So we're going to end up with this. Write that down. And then we're going to just simplify a little bit more the radical that's in there. We're going to do 64 minus 24, which is 40. So I will end up with 8 plus or minus the square root of 40 divided by 4. Now there's something important that you should know here. Since I'm looking for a number to plot, it's kind of hard to tell what a radical looks like to graph. So I will ask you to, at this point, if you're asked to graph, don't just reduce, actually find the decimal answer to it, so you know where to put the pointer. Now this is the plus or minus means that I'm going to have two solutions. I'll have x equal to 8 plus the square root of 40 over 4, and x equals 8 minus the square root of 40 over 4. So I'll have both components. I'll have the two x values. And there's deservedly so because there is two x-intercepts of this parabola. Especially what we saw, the vertex being shifted down, means that there's going to be 2. Now I'm going to bring out my calculator, as would you, and then we're going to compute. So when we do this, just go ahead and make sure you put parentheses. Sometimes if you don't put a parentheses, the calculator does not understand the correct order of operations. Sometimes you got to be deliberate and specific with it. You want to make sure it always calculates the numerator first, and then afterwards divide it with the denominator. So in this case, I find out that my first x-intercept will be 3.5811. Now, engineers round to 4 decimal places, so it's what I do in this class. 6? Oh, no, they do mostly 4. I mean, between them, they go ahead and use. So we're going to find the other one as well, too. Now, I'm going to bring up the same equation And I did that by hitting second enter. So if you want to get, sometimes save yourself some time, you could do that as well. But if I hit enter again, I'll get the other x-intercept, which is 0.4189. So 0.4189. And now I have my last two remaining points. So this is lovely. I have my two x-intercepts. This is one of them. The reason I'm writing this is that sometimes people don't understand that that's what I actually found. I found 2 points by setting y equal to 0, which was this. And that's what's going to be plotted, is those 2 points. So if I ever ask you what is the x-intercept, especially if they want an ordered pair, you got to understand that that's what it equates to. Now let's go ahead and actually plot them. So we got 3.5811 and then 0.4189. When I graph them, I have my 5 points, my vertex axis symmetry, my x-intercepts, and my y-intercepts, and I am done. It's lovely because I have 5 points. If for some reason you had a parabola that did not produce 5 points, the last step in your directions means that you have to look for one. For example, you see how the axis symmetry is 2? You could go ahead and identify the point that might be 3 and get the y values for either side. And that'll produce some other points. But now I'm going over the limit. I'll be producing like 7 points. Now, I want us to now move to another important topic we've covered. We said standard form is good, but in transformations and in identifying what the function does, we said vertex form is better. We said vertex forms makes it easiest for us to see the transformations within a parabola. And we did this. We found out how to convert from standard form to vertex form. Step 1, factor out an a. Then we found this new number that went inside of parentheses. The idea behind it all is that we would take a standard form of this and then make the vertex form. Now, if you go back and look at your notes, I want you to go ahead and look at the notes and see if you can recall what we did step by step. Because if I asked you to do this by yourself right now, some of y'all will be kind of hard pressed. Some of y'all will be looking at the notes and wondering, well, what did we do? So actually what I would prefer for us to do is write it down. I'll practice it with you again, and then I'll have you try it on your own on the next one. Now step 1, one of the things y'all wrote down when you worked on this, and especially if you're looking at your notes, step 1 was to factor out the a. So the a being 3, we just factor out to the first 2. So it would have looked like this. 3 is factor out. You're left with this new equation. Now you leave the c unaffected on the outside. And I leave a void. A void is basically the space. I leave a void because there is a number that will go in there that will allow me to complete the square. That's the whole idea. And that's actually what makes my vertex form, that void. Now, the number that I have to use to find out what that void is, on your notes, we would box it off. This is called the magic number. And it was just designed to be able to, at the end, come up with one parenthesis with the square outside. And I go into more details of what's going to go in there. I could tell you right now 3 will go in there. I probably could tell you more. But before we get into the details, let's come up with the magic number. Okay, now this is an old b. Y'all see the -6? Originally, this was a, b, and c. Okay, I'm going to write something down, which is take b divided by 2 and squared. This is what we would do to find the magic number. But hold on, before you write down anything, okay, this number is the new b, which means that y'all see this one right here? This is the new b. Yes, you will use the new b, not the old one, the new one, the one that was factored. That's what's going to use to produce your magic number. So when I use the new b, then UB will have -2 divided by 2 and squared will give me an answer of 1. That's the magic number. So the magic number will go in here as a 1. The only thing is that I really didn't put a 1 inside. It's more involved than that because it's inside the parentheses. If I decided to fold everything out or distribute everything out, I really didn't put it in a 1. What value did I really put inside that parentheses? One of the steps I did, or one of the steps in your notes, it says once you find the magic number, take your A value, multiply it with the magic number, and subtract it from the end. And you're wondering why. Okay. I went ahead, and by placing this 1, I really added a 3. That 1 really made a 3 because 3 times 1, it makes 3. But if I add a 3, I got to make sure I subtracted at the same onset to keep everything balanced. So it looks much cleaner up here. In this equation, it looks much more nicer to see, oh yeah, you could do that. You could add a 3, you could subtract a 3. But since I have it all jumbled in here, it's doing the same exact thing. Just that this 1 is this 3 hidden in there, and this -3 is what's keeping the balance on the end. The power that I'm able to do now is to this whole parabola, or this whole quadratic you see in the parentheses could be factored into. Well, actually, let me use red so it won't look so bad. X minus 1. How did I get the -1? It came from the b value. You take this b value and divide it by 2. Okay, so you may want to keep this present as to how did that -1 show up. Oh, and then at the end, the 4 minus 3 made +1. So I have now my equation the way I wanted it. Equation with the vertex form. So it's lovely. I have exactly what I'm looking for. A vertex form of the equation. What I like for y'all to do next is now apply these same steps and concepts with this one. This one's slightly different because we're dealing with the fraction. Erase this. But I want you to do step 1. I'm going to call on somebody randomly to do step 1. Remember, step 1 is to factor out that A. I will call you to tell me what your answer should look like. All right. Lovely. Let me go ahead and call somebody to look randomly. All right. 21, which is to here, or is it over here? You're 22? All right. So Daniel, what did you come up with? What was your oh, this got stuck. All right. Lovely. Okay. So what did you come up with? Yeah. What'd you come up as a result just from the first step? Oh, I see what you're saying. So did you come up with x squared? Did you get stuck at this next step? Is what you're saying? Okay. Yeah. You want to do it up here? Yeah, go ahead. Yeah. Yeah. Yeah, 2x, right? Now, before we do we don't want to involve the c. We're going to keep the c on the outside. because we're going to use that for other purposes. We just want to use the first two terms. But yes, now you might be wondering why 2. Well, 2 is the only number that will work. When you multiply a half back with that 2, it's going to produce the 1 that's necessary for the place value here. If you're dealing with the fraction, really the algebraic way to do it, but it's a little bit longer, it's easier to do it in your head. But supposing that you had like a really complicated fraction, could not do it in your head, you're really being asked to do this. You're really being asked 1/2 gets multiplied with the number that we don't know to produce the number 1, which is that same one that's here. That's really what we're being asked to do. So if you had to solve it, you will come up with 2. Multiply 2 to both sides, those kind of things. But we're in this instance, it was probably easier just to look at it and figure it out. Now let's from here, I want you now to fill that void with that magic number. I want you to calculate the magic number. I'm going to call in somebody randomly. All right, let's bring some excitement. If it worked. I thought I could do it over here. All right, 9. I think it's going to be you, Ethan. Hey, Ethan, what'd you come up with the magic number? You're not sure yet? Okay. Now, did you know, what was it? It's 1, yes. Yeah, for those who are wondering, now I normally draw a little box over here because it's a separate calculation. You're going to take the nu b and divide it by 2 squared, so it would have been just 2, the nu b, over 1 squared, which is 1, and then 1 here. Now think about what would be the number that needs to go on the outside to keep it balanced. Again, figure it out. I'm going to call somebody randomly. You should know, either you know it or you don't, so I'm going to call somebody randomly quickly on this one. Nine. Oh, Ethan again. Ethan likes you this time. Refresh. Just there's a 1 out. What is it? What would be the number that goes on the outside? Well, not necessarily. Actually, you need to take the value that is a, multiply it with a 1, and then subtract it on the outside. So, yeah, negative 0.5, negative 1/2. Since we're dealing with fraction, it would be negative 1/2. And those that are wondering what we just did, we really added 1/2 and are subtracting 1/2. It's kind of what we did with that 1. We added this 1/2 is this 1 hidden in there, and that's this one. All right, now I want you now to come up with your final result. Now produce the final answer. I'm going to call on somebody randomly to share what that is. Let's see what y'all got as a final answer. 10. Should be actually this case. What was your name again, sir? Jacob. There we go, Jacob. All right, so Jacob, what did you end up getting as the final answer? Mm-hmm. Either 1.5 or 3/2. Yeah, 3 over 2 of 1.5. So let's go ahead and write in 3 over 2 since we're dealing with fractions. Yes, that would be the exact answer, and you're done. You have now your vertex. You have it in vertex form. It's lovely. Now, what I wanted you to do for the rest of the time we're here, you have about 15 minutes left. Is it 15? Yeah, you have about 15 minutes left there, is now to reinforce the skill. On the first 3 problems, actually the first 3 pages, I think what they want you to do is I know the first couple of problems they want you to convert it from standard form to vertex form. Okay, so go ahead and start doing that.